graphs of exponential functions. What we saw, so in the case where b is greater than 1, okay, this is the picture that we saw. And what we saw was that it crossed here at 1. And that's always going to be the case, because if you raise a number, a non-zero number, to the 0 power, we know that we always get 1. Okay, so this is always going to be 1 for every single exponential function we can conceive of. So that's an important thing to remember. It always crosses here at 1. We also see that this line, the x-axis, is a line that the function approaches as we go to negative values of x. What that means is that this line is a horizontal asymptote. An asymptote is a line that a graph approaches. It may not reach that line ever, and that's the case here. It never actually gets to the x-axis, but it gets closer and closer and closer the further you go to the left. And this x-axis has the equation y equals 0. Now, what's the situation when b is less than 1? Actually, maybe we should just go back to the computer and take a look. And I'm going to look at different values for b here. So here's what it looks like when b is 2. We get this. If I make b bigger, what's going to happen? Well, the graph gets steeper. And that should make sense, because you're raising larger numbers to a power. You should get even bigger numbers, right? So you can see as b gets large, it gets steeper and steeper. When b starts to decrease and gets close to 1, you can see it flattens out a little bit. b is not allowed to equal 1, because at that point it just becomes a straight horizontal line. But it still makes sense. It's just we don't call it an exponential function. Look what happens when b dips below 1. Oh, look at this. It flips. It does the same thing it was doing before, but it's on the other side. And when b is a half, it's actually the mirror image of when b was equal to 2. And we can think about why that's the case. This is exactly a mirror image of when the b equal 2 case. So when b is less than 1, we get a graph that decreases from left to right. So when b is less than 1, we know it still has to go through 0, 1. Its y-intercept is always 0, 1. In fact, maybe I should put that down, since we've talked about y-intercepts before. That's the y-intercept, 0, 1. Same thing here, except now our function looks like that, right? So it decreases from left to right. Still has a horizontal asymptote. That's still the case. Still has a y-intercept 0, 1, but the graph decreases from left to right instead of increases. This is called exponential decay. This one up here is called exponential growth. The two different behaviors we can see with exponential functions. So it either grows very fast or it decays very fast.